Today we're going to be talking about the next type of conic, which is called an ellipse. So here's the first equation we're going to analyze. You also notice I put a bunch of 3D boxes down, so we'll be going through them as we go through the problem. But I first want to show you that graphing these is quite simple. Notice how it's x squared over some number plus y squared over some number and equals 1. So in our first 3D box, this right here is going to represent a generic formula for an ellipse. And notice how it's a squared and b squared on the bottom. So this number is always going to be a squared right here and b squared right here. Now the way it works is quite simple. It's very similar to a circle. So the centers are going to be at 0 for now. So I can put my C right there. And in my info box, I'm going to fill that in. The center is 0, 0. And notice how this is a squared, which means right here, a is 5 and b is 3. So I'll simply take the square root of each of these. What this tells you is how far out to go in each direction. So in the x direction, we're going to go 5 out. 1, 2, 3, 4, 5. Mark it. 1, 2, 3, 4, 5. Mark it. And right here, it tells you in the y direction, you're going to go 3 out. 1, 2, 3. 1, 2, 3. Now connect it. And notice how you have this nice oval shape. That is your ellipse. And for the most part, that's the basic idea. Now, of course, we got to go through the details now. So this is like the basic skeleton of what we're doing. We're first going to talk theoretically, like what is happening right here? Like what is an ellipse? So on the top of our papers here, I'm going to give you the definition. An ellipse is the set of all points whose distance from two fixed points, and we'll call them foci, remain constant. And that's going to be the plural of focus. Okay, so to model this, I'm going to show you a video. So right here we have an ellipse, and notice how as the dot is moving, that red and the blue line will always add to the same number. So that's what it means when it says the set of all points whose distance from two fixed points remain constant. So you can see right here that blue dot and the red dot inside the ellipse, those are your foci points. And as the dot along the ellipse is moving, the distance is remaining constant. You also notice a couple of interesting things here. I'll pause the video right about here. Go back right about here. Notice that right at the middle, the red line and the blue line are about equal. And look at the bottom. The red plus the blue, that basically covers the entire ellipse. So we're really going to use that idea today as well. So over here, we're going to generically sketch it. I'm just going to put some lines here. So here's a generic ellipse, and the orientation is important, so make sure you copy my orientation. Your foci points are always inside your ellipse, so put it generically like in here. And then we do have vertex points. The vertex points are going to be right here, right along your x-axis. And then the other points are going to be, I'll put that up here. We're going to call those EMA. And EMA is going to stand for end of the minor axis. Now you're probably wondering, how did we decide that these two are the two vertex points, where these two are the EMA points? Now the way you know that is this. the vertex points lie on the major axis, meaning the longer one. So in this case, we're saying that this value is bigger, and your EMAs lie on what's called the minor axis. So a little detail we're going to add in here is that this formula is the assumption that A is larger than B. So if A is larger than B, and it's written like this right here is our orientation. Notice how it's longer on the x-axis. In class, we'll sometimes refer to this as like football form, because it kind of looks like a football like this. Now the other version over here, it's going to be x squared over b squared plus y squared over a squared, that equals 1. Notice how it's identical, except a and b switch. So it's still, the assumption is that a is greater than b, but notice where the a is right now. If a is there, the orientation is going to flip around to something like this. Your ellipse is going to be going up like that. And I'll sometimes call this corn form. So think of like a corn growing in a field. So in this case, your vertex points are at the top, and your EMAs are on the side. And of course, your focus points are going to be right in here. So also notice something else here. Your foci points lie on the major axis. Okay, that's quite a bit of information. We're going to add a few more things now. Now that we have these pictures, we can kind of detail them a little further. So the center to your vertex, like that, that's your A value. The center to your EMA, that's your B value. And then center to the focus point, that's your C value. So again, I'll do it over here. The center to the vertex, that would be your A. Center to EMA, that would be B. And center to focus, that would be C. Okay, so that's quite a bit of information. So let's go back to the original problem now, and let's fill in what we know. So in our info box, I have my vertex, we have EMA, and then we have the foci, or the focus points. So vertex now, I can see that this one's bigger, so our vertex points should be along your x-axis. So we're going to label that V and V, and now I can say that would be plus or minus 5, 0. Our EMAs are here, the shorter axis, so let's label that EMA, that's 0 plus or minus 3. The last thing is the focus point. So we know, right here, we'll do this box now, C is the distance from the center to the focus. I should put foci, because there are 2 of them. But we haven't talked about how to find it. So here's how we find it. There's a very nice formula we use, and it is C squared equals A squared minus B squared. So first I'll use it, and I'll kind of show you where it comes from, but I'll show you how easy it is. So we're going to use that formula. C squared equals A squared minus B squared. So C squared should equal A squared is 25, B squared is 9, so C squared is 16. In this chapter, I'm not going to make you do the absolute value of C equals 4, because we're always going to take the positive number here, so you can just go straight to 4. That's going to be fine. Which tells us the focus is 4 points or 4 units away from the center along the major axis. So there's our focus 1, there's our focus 2, and we can label it plus or minus 4, 0. Now you're probably wondering, this formula, where'd it come from? So I want to show you really quick over here. So here's a generic ellipse. And you might remember that video I showed you right here. I paused it. This is super important. Notice how the two lines, the red and the blue, they add to the major axis. So I'm going to use that fact here. So if I have a focus here, I have a focus here, I'm going to draw that in here. By doing that, I create a nice right triangle. I know that this distance right here is C, from here to here, and this is my V, this is my EMA, which means this distance right here is B. The only issue is I don't know this thing. This is a question mark. But since it's in the middle, I know that these two things are the same value. So I'll put question mark, question mark. But look back at the video here. The two lines add to the entire thing, which means the question mark plus the question mark equals the length of the major axis. And the major axis is this whole distance. And if we know that this thing is A, the length of major axis is going to be 2A, which means 2 times the question mark is 2A. The question mark must be A. So now I can erase that. And there we go. Now we can derive it, because that would mean we have a triangle where B squared plus C squared is equal to A squared. So therefore, C squared equals A squared minus B squared. That's why it looks like the Pythagorean theorem, because it's derived from it, but the numbers, or not numbers, the letters was different because of the letters we're given in our ellipse. So if you're wondering where it comes from, that's the idea. Okay, so I know that was a lot of information, so we'll do one more problem, and then we'll do a quick recap. So now it says, find the equation of the ellipse with center at origin, focus at 3, 0, and the vertex at -4, 0. Graph the equation. So let's quickly start by making our info box. Our center is 0, 0, and then vertex, EMA, and our focus points. I'm going to sketch. Center. And let's fill in what we know. We have a focus at 3, 0, 1, 2, 3. And a vertex at -4, 0, 1, 2, 3, 4. So by symmetry, since we know the ellipse is symmetrical, a vertex here means there's a vertex here. And a focus here means there's a focus here. So already we can fill that in. Plus or minus 4, 0. And our focus is plus or minus 3, 0. The only issue is we don't know the EMA. So what you're going to do is use that formula I showed you. C squared equals A squared minus B squared. I know C is 3, so 3 squared is equal to, I know A because I know the vertex. Remember that A is always with the vertex. So that's going to be 4 squared. And now we just solve. 9 is equal to 16 minus B squared. B squared is 7. So B is the root of 7. And again, for this chapter, no, you can skip the absolute value because we're only going to take the positive answers anyway. So root 7 means we're going to go up root 7. So 1, 2, 3. 1, 2, 3. Root 7 is between 2 and 3. So we'll just mark that right here. So for these, we're just estimating. We don't need the exact value. And then let's sketch it. And we can fill in our EMA. And now the final touch is to make the equation. So x squared over something plus y squared over something equals 1. What I do is I look in the x direction. I'm going 4 out, which means this is 4 squared, or your a. I'm going in the y direction, root 7, so square that, and that's 7. And there's our equation. The only thing to be careful of is always make sure your orientation matches your equation. If this number is bigger under x, that means you have football form. If the y number were bigger, you have the corn form. That's the main thing to be aware of. We're going to take a little section right here. This is the first ellipse we worked on. This is the football form. That's your x squared over a squared plus b squared, y squared over b squared is equal to 1. And if we crop this thing, and we're going to rotate it, right here, now we have our corn form. So exact same thing, except the A and B switch. We're going to label our vertex and EMA, like so. And I'm going to put a couple notes down. So the vertex lie on the major axis. Your EMA lie on the minor axis. I'm going to put in parentheses A and B. So I'm going to note here, right, this distance is A, that's B. This distance is A, B. This means the length of the major axis equals 2A, because obviously A plus A would be 2A, which then means the length of the minor axis, that would be 2B. So let's highlight that. And of course we have our foci points, we'll put those in. F, 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 F. So I'll put focus points lie on the major axis, and that relates to C. C is the distance from the center to foci points. And the final thing that ties everything together, C squared equals A squared minus B squared.